go ahead and split your notebook into 6 sections with the title of Angles and Their Measure Part 1. And then you'll do a second page, very similar, 6 sections that says Angles and Their Measure Part 2. Welcome to another pre-calculus review video. Today's video is on angles and their measure. This is part 1. So now that we know about angles can be in degrees or they can be in radians. We need to know how to sketch different kinds of angles. Okay, so an angle in standard form, and this is my first vocabulary word for today, is an angle on the Cartesian plane. And if you're like, what is the Cartesian plane? The Cartesian plane is another word for the XY axis. Okay, so the formal definition of the axis, the XY axis, is the Cartesian plane. So when I have an angle on the XY axis, or I have an angle on the Cartesian plane, that is going to be an angle that is generated by the vertex on the origin, the initial side on the positive x-axis, and a rotation of the terminal side. And we're going to break this down a little bit further so you guys know what I'm talking about here. So firstly, it says that I need to have the vertex on the origin. So we're going to try doing that first. So the vertex of this angle is on the origin, and the origin, remember, is 0, 0. So there it is. Then it says that you need to have the initial side on the positive x-axis. Well, here's my x-axis, and the positive x-axis is to the right. So this is my initial side. And then I need a rotation of the terminal side. And I'm going to use red again. Rotation of the terminal side. So I need to rotate, and that can be anywhere. I can rotate up to here if I would like, of the terminal side. So an angle on the standard form is going to be just like this, with the vertex at the origin, the initial side to the right, and then the terminal side that's being rotated. Okay, so using this as an example, we're going to go ahead and sketch 135 and 210. Okay, and they tell us that when we rotate in the counterclockwise direction, that creates a positive angle. And when I rotate in the clockwise direction, that's going to create a negative angle. So starting with my vertex at the origin and my initial side on the positive x-axis, we're going to go ahead and sketch 135 degrees. Now, remember from geometry that a perfect corner, like the one on the screen, is 90 degrees. So I'm going to use this to kind of estimate how to sketch my angle. So if I start with 135 degrees, and I know for sure I can graph a perfect angle of 90 degrees. Let's start with doing that first. So here's the 90 degrees I'm going to cover, right? There it is. On top of the 90 degrees, I need to travel another 45 degrees. And 45 is about half of 90. So if I travel another 45 degrees, this is the angle of 135 degrees. This angle that's created in here. Okay? And that makes sense because 135 degrees is an obtuse angle. Alrighty, let's go ahead and sketch negative 210 degrees. And remember that for this angle, because it's negative, instead of going upward in the positive direction, we're going to be going downward in the negative direction. So if I have 210 degrees, I for sure can graph 90 degrees, right? So let me draw my 90 degrees. From the leftover angle of 120, I can still draw another 90 degrees. So here's my other 90 degrees. And then lastly, I'm left with 30 degrees. And remember that 30 is 1/3 of 90. So this next 90 section, I'm going to cut into 3 sections, and I want 1/3. So there it is. I don't need this part anymore. And so this angle going in the negative direction is negative 210 degrees. Now looking at these two angles, I also need to determine what quadrant am I in. And if you remember from pre-calculus, this is my first quadrant. Here is my second quadrant, third quadrant, and fourth quadrant. And I'm going to do the same to the other side using Roman numerals. And so where did I land for 135? I landed right here, 135. And that is in the second quadrant. So I'm going to say second quadrant. Okay. Now let's look at my next angle. I also happen to land in the second quadrant for this example. It won't always happen, but for these two, these are both second quadrant angles. Okay. Now, is it possible to not land in a quadrant at all? It is. And so a quadrantal angle is an angle whose terminal side lies on an axis instead of a quadrant. So what does this look like? Let me show you an example. Let's say I have, I don't know, something like 90 degrees itself. Well, 90 degrees is a perfect corner like this. And so if you notice, it doesn't land in quadrant 1. It doesn't land in quadrant 2. It lands right between them on the axis. And so when this happens, we would say quadrantal angle instead of saying what axis we landed on. Another example of this would be, let me give you a negative example. If I had, for example, negative 180 degrees. Negative 180 degrees would be in the negative direction. And I know that 180 degrees is the same as adding 90 twice. So I'm going to have 290 degrees in the negative direction. And if you notice, again, negative 180 lands between the second quadrant and the third quadrant. It's right in the middle. So this would be a quadrantal angle as well. We're going to do some more sketching practice here of some larger angles. So we're going to sketch 510 degrees. So I'm going to start by creating my initial side and my axis. And when you have really large angles, like 510, I know that a full circle is 360. So instead of subtracting 90, I can subtract 360. And after doing a little bit of math here, I'm going to get 150 left over, but we'll do that next. So the first thing I can graph is positive 360 degrees, because this is a positive angle. So 360 degrees is a full circle. Okay, and instead of these two touching, I made them a little bit to the side so I can keep swirling around if I need to. Okay, so after I do my full circle of 360, I still need to travel 150 degrees. Now from here, I can travel another 90 degrees, right? So another 90 degrees would look like this. And then I need to travel 60. And remember that for the 30 and the 60s, those are thirds of 90. So I know that this section is 30, this section is 30, and this section is 30. And I want 60. So I would need to travel 2 of these sections, which would put me right here. And so this is the angle of 510 degrees positive. And I don't need these sketches, so I can go ahead and get rid of them. Great. Moving on to negative 765. So same thing. These are really big angles. So I'm going to start by seeing if I can graph 360 at least. This is going to be in the negative direction. Great. I could for sure graph 360 degrees in the negative direction. So going downward a full circle. Okay. Can I do another 360? Yes, I can. And I'm going to be left with 45 degrees. So I can do a whole other 360 in the negative direction. So a whole other circle. There it is. And now I need to travel 45 degrees. And remember that 45 is about half of 90. So here is my other half that I traveled. And this would be the angle of negative 765 degrees. And that would be the angle of negative 765 degrees. Now, the last thing I need to do is determine what quadrant are these angles in. So, my first angle of 510 landed in the second quadrant. And then my negative angle of 765 landed in the fourth quadrant. Awesome. Now, my next vocabulary word for today are coterminal angles. Coterminal angles are angles in standard form that share the same terminal side, and they can be found by adding or subtracting 360 degrees. So, what does this mean? If I were to sketch 120 degrees, that would be 120 is 90 plus 30, should put me about here. Okay? So this is my 120 degrees. And I want to find another angle on the same terminal side. Now this means that I could have another angle that maybe loops around one time, but stops at the same place as 120, right? This visually could also mean that maybe I go in the negative direction and I stop at the same location as 120. This could also mean that I loop around one time in the negative direction and stop at 120, right? And this also means that I could loop around 2 times and stop at 120, 3 times and stop at 120. And I could do this over and over and end up with hundreds of angles that stop at the same place as 120. I could do this thousands of times, hundreds of thousands of times, and hopefully you're seeing where I'm getting here. I could do this millions of times, and ultimately I could do this an infinite amount of times. So on this ray of 120 exists an infinite number of angles that could share the same place as 120. And I could figure out the measurement or the value of all of these angles by adding 360 over and over and over and over and over again an infinite amount of times. And I could do the same subtracting 360. And I could find all the negative angles that land in the same place as 120. And there's an infinite amount of both positive and negative angles. So, for the sake of this problem, I just need to find one negative coterminal angle. So, I'm going to take my 120 degrees, and because I want a negative coterminal angle, I'm not going to add 360, I'm going to subtract 360. And I'm going to get negative 240 degrees. So let's graph negative 240 degrees, okay? Well, I know that I can for sure graph 90 in the negative direction. Negative, okay? So I'm going to go down 90. And that's going to leave me with 150. I can for sure graph another 90 degrees. Should be here. And then lastly, I need 60 degrees. Well, I split this one up in 3 sections, and 60 means I would travel 2 of them. And look at that. I end up in the exact same place as positive 120. So this is just an example of 2 angles that share the same terminal side and they land in the same place. Okay. For this example, I need to find a positive and negative coterminal angle for 45 degrees. So to find my positive coterminal angle, I'm going to take 45 degrees and add 360. And I'm going to get 405. And for my negative coterminal angle, I'm going to take 45 degrees and subtract 360. And that's going to give me about negative 315 degrees. Okay. So let's see if these land in the same place as 45. Well, first let's graph 45. Here's my initial side. 45 is half of 90. So here's 45 degrees. Now let's graph 405. I'm going to do that one in blue. So to graph 405, I know that's a full 60, 360. So I'm going to graph positive direction, a full 360 degrees, and another 45. And yep, I land in the same place. Now let's do the negative angle. Here's my initial side. I know it's getting a little messy. I'm going to go for 315. I can for sure travel 90. And 315, if I were to take away 90, I'm left with 225. So I could for sure travel another 90. Here's my other 90. Okay. And I'm left with 135, so I could still graph another 90 degrees. And lastly, I'm left with 45, which is about here. And so all 3 angles land on the exact same place. I know they're a little bit off because I wanted you to see all 3 colors, but really they're all landing on this terminal side. And if I were to add 360, I'd find another angle that lands in the same place. And likewise, if I were to keep subtracting 360 as well. Okay, so now that we learned all of these angles in degrees, we're going to do the same with radians, okay? Now for radians, it can be a little bit tricky. So I'm going to try to use some visuals to show you how to represent different angles in radians. So we know that 360 degrees is the same as 2 pi radians. And I know that 360 is a full circle. So 360 would look like this, right? A full circle is 2 pi. Half of 2 pi is pi. And half of 360 is 180. So if I wanted to graph 180, I would have to do 2 90s, which would be a half circle. Okay? Half of pi over 2 is the same as 90 degrees. So this would look like a quarter of a circle. Okay? Pi over 4 in degrees is the same as 45 degrees. which means that that would be about half of 90, which is a quarter of a circle. And lastly, pi over 3 is the same as about 180 divided by 3 is 60, and that is 2/3 of 90. Okay, so I'm going to use these estimates to try and graph my degrees in radians. So for my first example, I have 3 pi over 2. So I could graph 270 degrees, and at this point, you guys already know how to do this, right? But another way so that I can begin to conceptualize graphing in radians, well, I know this is 3 pi over 2's. So how much is 1 pi over 2? Well, let's look over here. Pi over 2, here it is a quarter of a circle, right? So if I want 3 pi's over 2, I'm going to need 3/4 of a circle. So let's graph 3/4 of a circle, okay? Here's 1/4 of a circle, 2/4 of a circle, 3/4 of a circle. So here is 3 pi over 2, okay? Now, I want 5 pi over 4's. So how much is pi over 4? Well, if we come back over here, pi over 4 is a 1/8 of a circle, right? So I'm going to do 5/8 of a circle. So here's, well, let's see. That would be, these are all divisions of 8. And I need 5 of them. So I'm going to go 1/8, 2/8, 3/8, 4/8, 5. 5/8 of a circle, but 5 pi's over 4. Now, if you're kind of following how to graph these radians, but you wish there was an easier way, I do have a kind of like a trick or a formula. So to sketch an angle in radians, and this is the way that I like to explain to my students that we graph angles in radians. You're going to divide the entire axis by twice the denominator. Then the numerator will indicate how many sections to rotate, okay? So, an example, if I had 2 pi over 3, twice the denominator means I take my denominator of 3 and I multiply times 2. And that means that I'm going to divide my entire axis into 6 sections. So, 6 sections, that means 3 on the top and 3 on the bottom. So there's 3 on the top and 3 on the bottom. 1, 2, 3, 4, 5, 6. And out of those 6 sections, I'm going to rotate 1, 2 of those sections. Okay, so we're going to do more practice. Let's do another problem. Okay. Jumping into this problem, we're going to be sketching 11 pi over 6. So because my denominator is 6, this means I need a total of 12 sections. 6 on the top and 6 on the bottom. So let's go ahead and divide the top first. So I already have 2 sections. I need 6 on the top. There's 6, 1, 2, 3, 4, 5, 6. And I need 6 on the bottom. Okay, there are my total of 12 sections. And out of those 12, I need to travel 11 of those sections. And this angle is positive, so I'm going to go upward in the positive direction. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here would be 11 pi over 6. Okay. Now we're going to sketch 4 pi over 3. Okay. That means we're going to divide pi into 3 sections. I'm going to divide the top pi in 3 and the bottom pi in 3 to give me a total of 6 sections. Okay. So I'm going to create a total of 6 sections. So on the top, I want 3. And on the bottom, I want 3. Now, it's kind of tricky because whenever I do these kinds of problems, some students have a difficult time ignoring the y-axis. If you ignore the y-axis, I have 1, 2, 3, 4, 5, 6. But you need to pretend that the y-axis is not there. Because students will divide it into 3 sections and then they'll go 1, 2, 3, 4. They'll count the y-axis as another section and no, that's wrong. So you have to be careful, okay? So here I have 3 sections in the top, 3 sections in the bottom for 6 sections total. And I need to travel 4 sections and this angle is positive. So here we go. 1, be careful to ignore the y-axis. 2, 3, 4, ignore the y-axis again. Oh, and I only want 4. My apologies. There it is. So here I have 4 pi over 3. Okay. And similarly, if I wanted to figure out what quadrant these are in, I could see that this is a 4th quadrant angle. 4th quadrant, and this one here would be a 3rd quadrant angle. Okay. Now, in the same way that I have coterminal angles for angles in degrees, I have coterminal angles for radians as well. Coterminal angles are angles in standard form that share the same terminal side, and they can be found instead of adding or subtracting 360. Remember, 360 is the same as 2 pi in radians. So they can be found by adding or subtracting 2 pi instead of 360. Okay? So they're asking me to sketch 4 pi over 5 and find a positive coterminal angle. So first, let's start by sketching 4 pi over 5. And I know that 4 pi over 5 means that I'm going to create a total of 10 sections, okay? So 10 sections on the top and on the bottom. Or 5 sections on the top. 5 sections on the bottom for a total of 10. And I need to travel 4 of these sections. So 1, 2, 3, 4. Here is 4 pi over 5. And I want a positive coterminal angle. So I'm going to be adding 2 pi. So I'm going to say 4 pi over 5 plus 2 pi. Now, can I add these two fractions if they do not have the same denominator? No. We need to get them to have the same denominator. So if I multiply by 5 over 5, I get 10 pi over 5, which gives me 14 pi over 5. Okay, so this means if I have 14 pi over 5, then I need a total of 10 sections. Great, so my sections does not change. But instead, I'm going to be traveling 14, okay? So I already have my 10 sections, and now let's go ahead and travel 14. So I start here. I'm going to travel 14. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I end up in the exact same place as 4 pi over 5. Okay. Last problem here. I need to find a positive and negative coterminal angle for negative 13 pi over 3. So let's find the positive one first. And I'm going to do this by adding 2 pi. We need the same denominator. And so I have negative 13 pi over 3 plus 6 pi over 3. Okay? And negative 13 pi over 3 plus 6 pi over 3 is negative 7 pi over 3. So be careful because I want a positive coterminal angle. And even though I added 2 pi, I'm still left with a negative value at the end. So you need to add 2 pi again. And remember that once I multiply by 3 over 3, that's going to be the same as 6 pi over 3. So if I add 6 pi over 3 again, I get negative pi over 3. This still isn't a positive value, so I need to add 6 pi over 3 again one more time. And I'm left with 5 pi over 3. So sometimes you need to add 2 pi over and over again until you get a positive value for your positive coterminal angle. Now let's do negative. So I have negative 13 pi over 3. And instead of adding 2 pi, I subtract 2 pi. And remember for this problem, instead of 2 pi, I'm going to do 6 pi over 3. So it has the same denominator. And I'm left with negative 19 pi over 3. Okay, let's go ahead and graph these. So I need a total of, my denominator is 3, double 3 is 6. So I need a total of 6 sections. 3 on the top, 3 on the bottom. And we're going to start with the positive angle of 5 pi over 3. So I need to travel a total of 5 of these sections. 1, 2, 3, 4, 5. And now we're going to travel in the negative direction, 19. Okay, so going down, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And as you can see, we end up on the same terminal side as 5 pi over 3. So we know we did everything correctly. Thank you everyone so much for watching, and hopefully this video was helpful.